serving Delta Lake, how, when, and why. The whole point of this presentation is that Delta Lake is somewhat has become, not to say status quo, but it has risen in popularity in the world of data. And serving it, like most of data people, data engineers and stuff like that, we tend to think about serving it like tables and views, but there are a lot of different scenarios on what you might want to do other than just tables and views. So to go forward, won't work here. So a little bit about myself. I'm basically just a data enthusiast from Finland. I currently work as a senior data engineer at Cloud1. My main work it revolves around Azure and Fabric and Databricks and all this data platform kind of stuff. It's a lot of different things I do. It's not just like a couple of years ago, almost mainly I did just SQL kind of stuff, but now PySpark and like networking and infrastructure as code, CI/CD pipelines, the whole thing has just evolved a bit. And I think the role of a data engineer has changed quite a bit in the past couple of years. I also did my master's in economics and business. Actually, I did it in accounting and finance. So I'm not sure how I ended up here. I did some technical courses in university as well, and things just kind of evolved from there. But enough about me. What is Delta Lake? The presentation is not going to be a deep dive on how Delta Lake works and what it is, but just to give you an idea. It's basically just an open source format that utilizes Parquet files. So to think about it, it's just a folder, and inside that folder is Parquet files, and you can query that folder just like you would query a regular table in a SQL environment. The cool thing is that Delta has a lot of different optimizations, and it's ACID compliant. You can do time travel. So if you mess something up, you can basically just travel back to the previous state that the table was in and store that. So if you mess something up, it's really easy to recover, basically. And how does the reading part actually work? Because that's something that is a key point in this whole presentation. So like I said, it stores data in a folder, and inside the folder, there are subfolders and the Parquet files, the whole data itself. So by definition, Parquet files store some statistics, like min and max value, so you can do data skipping. So basically what you would do is you are querying your Delta table, and let's say you have columns 1, 2, 3, and you have some like statistic like age, and you want age to be over 20. So when you query it, it knows that, okay, you have Parquet files, and only 2 have age that is over 20. So we can just look into those files as well. And also, because you have time travel, you can there's this thing called transaction log, where it basically stores every single transaction that you do to that table. So if you have inserts or deletions or stuff like that, the table knows where it's at currently. And it also stores these kind of checkpoint files. So when you query the table, and let's say the table is fairly old, and you have lots of transactions done to it, it doesn't have to do basically a full table scan, or it doesn't have to read the whole file. It can just look the latest checkpoint files and go from that. So that's really, really cool and neat. Yeah. So, but I already have data served. This is basically something that I was saying earlier, that we as data engineers sometimes think about when serving data is just tables and views. And once we've done tables and views, that's it. And we have our nice catalog set up and everything, and reporting needs have been met. But I think more and more we have things, it's not even all about IoT, it's just we need to maybe stream or serve the data to applications, and applications have different requirements than us as people or reporting needs. Like, I think most of us could agree that if you have a Power BI report and it refreshes and you might have to wait like 4 or 5 seconds to do so, it's fairly, or most commonly, it's not a big deal. But when it comes to applications, 4 or 5 seconds is often way too long. So we need to think about the whole idea on what we mean when we actually serve our data. And when we are designing and building an API, we need to maybe shift our focus a bit more on application needs and develop and like latency stuff and like that. But so, where do I even start? This is a really, really key thing in this presentation. So I always say that the business and use case comes first. So you don't want to maybe build something just for the technical sake of it, even though it might sound really cool and you feel like you get pleasure out of building it. You can do that if it's your hobby or you're doing just some proof of concept stuff. But if you are actually like designing a piece that's going to be in a production environment, you need to think about the business and the use case first. And the most common scenario in these on why I emphasize this is the fact that the best case scenario is you don't even need to build anything. Like you just need to think about who actually uses the data and what do they need. Like business users might sometimes say that they need low latency out of like an application, but low latency maybe isn't equivalent to the fact that you need to refresh your data, for example, constantly. And most of the time, if you think about building your own solutions and then checking that most modern lake houses like Fabric or Databricks, they offer some sort of SQL endpoint. They are a bit slow, but they are really easy to use and to maintain. And I think for some at these scenarios, this might be the optimal way to go because you'll just put out like some Azure function and then from there you script like a query to the SQL endpoint. I've done a few with Databricks at least, and it's really easy to set up. The main problem is the latency. It takes time if your compute isn't up, so it needs to spool a compute up or use an existing one. And even still, it's a bit slow. So it's, I'd say, in the tens of seconds most of the time. But if you query the data, like let's say once or twice a week, or even once a day, and you're okay with the latency, that's really a good way to go forward. But then there's the other scenario. You want more. Most of the time, if you're working with software people or building an application, then you say that we have latencies up to 10 or 20 seconds, they will laugh you out of the room. So you need to think about something that offers you more control and less latency. So this obviously means more work. You might not be able to use the existing SQL endpoints. And still, in this case, you need to evaluate the business case. Most of the time, or not most of the time, but some of the time, business people actually just think they want low latency, but they don't actually need it. So you need to build like good is good enough. If this is something that you only are doing once, it may be sensible to think about like if we can just handle being like in the tens of seconds with latency and then save money with that. If it's actually a business critical need that you need to have the data coming in and refreshed like sub-seconds or something like that, which is usual case for these APIs, then we can go ahead and go forward with our case. Basically, all options in here, firstly, are to check out if the lakehouse endpoints are good enough for you. Like I said, very little setting up. It's maybe 1 or 2 work days. One work day, I would say, to get it up and going. Setting up to production and stuff like that maybe take a little bit more, but it's really, really easy to use. But they're slow. That's like the downside of it. But then are the options when you need low latency. Using a SQL database, so basically how this will work is that you will replicate your existing Delta tables to a SQL database, and then you can use a function or a logic app or whatever you like to call it. This enables you to use the low latency solutions, but the downside is that you have to have like duplicate your data to some existing SQL database, which obviously it costs money. And then the other fact is that sometimes you it's a funny thing, like you can have stuff in like maybe different blobs in your Delta Lake stored as Delta tables. But then if you want to replicate them to a SQL database, sometimes clients want them to be separate SQL databases. So 5 tables might need 5 databases, and that's really, really, really expensive. But like I said, if you are doing this like a one-time thing, and you just need to build something that will work and is easy to use, definitely go with this. I would say one downside is that you are stuck in SQL. I know this will trigger someone because I'm a bit bashing SQL here. But for example, if you want to do some visualization queries or some like maybe a bit more hardcore data stuff, SQL might just not cut it out for you, and you might need to use some Python libraries. So, and you're again replicating to this database. And then the other thing is that you need to have some existing pipeline that will replicate this data. That's not really an issue that's only in this kind of scenario, but it is definitely something that you need to think about. Then off to the next one. Polars. So I think most of us, or at least some of us, have heard about pandas. So Polar is basically a cousin to that in somewhat form. It's a Rust-based library, so it's relatively fast. And the cool thing is that you can read Delta natively and parse it to JSON. And after that, it's up to you on how you serve it. You can use functions, you can use container apps, whatever you like. And we're going to be talking about container apps and the whole building image thing a bit later. I have to say that Pandas also offers some Delta Lake support, but it's not really that common. I'd say Polaris is basically the new player in town, and it has frequently, I'd say, risen even over Pandas in some shape or form. But the cool thing is that you don't need to replicate the Delta data anywhere. You can just read it straight from your Delta Lake or OneLake, but whichever you have, and then parse it to JSON. Obviously, you need to do maybe something that's on how you serve it. Use like Flask or Fast API or some other tools, but that's really, really up to you. Then the fact that, or the thing that I'm most excited about is DuckDB. And I know there are people who are saying like, so you're saying that creating a SQL database is maybe bad, but using a DuckDB is good. Like, how does this stuff work? So DuckDB, if you don't get anything else out of this whole presentation, I would say try and install the DuckDB CLI and play with it. It's really fun. It's really easy. And for example, if you have to do some Parquet file debugging locally, this is the way to go, I would say. They offer clients for almost every language, and they also offer CLI. They offer SQL clients, whatever you want to use. But the point here is that you don't use DuckDB as a database. It's more of a like a query engine. So what I did is that you build basically, you import the DuckDB Python client, and then you build like a query that queries Parquet file or Delta Lake files straight, and then you utilize that basically. So you utilize this the same way as you do Polars. You don't necessarily create tables with it. You don't materialize anything. You just use it as a query engine. And that's a really cool way to do it. Later, we're going to check some performance regarding on how this thing works. But DuckDB and Delta Lake is fairly fast. You can get, depending on your queries, you can get somewhere around a second. But the next thing, and the thing that I think for most people is currently the way to go, is Parquet pipeline plus DuckDB. So how does this work? Basically, the idea in this is that currently DuckDB, you can read Delta. It's fairly new. It has come like 6 or 7 months ago, and it's still in beta. So it's going to get a lot faster. But if you don't have the time to wait for it, this is the way to go. So you would replicate your Delta table as a Parquet file, a single Parquet file. You can obviously do some partitioning. You can do multiple files if you want, but I would suggest maybe 1 or 2 files is almost always enough. Parquet files, if you don't know, they take very, very little space. So it's a lot less expensive to do than setting up a completely new database. And with this, you can do really, really low latency stuff. You can get way under a second. So as you soon will see, I will show you a demo. It isn't as fast that I say this in this, mainly because of the fact that the query is stupidly large, and the when you're using like a browser, it takes a while to load up, but you just have to take my word on that. And obviously, when you're building stuff, you need to think about like where are you actually storing your data, where you're reading it from, and stuff like that. But this works really, really great. So, but that isn't enough for you. You want even lower latencies. And this is actually a cool topic to discuss because caching is something that software people, they think about this a lot. Like you think about applications or talk about developing applications, people tend to think caching like really quickly. But when you come to the world of data, like I said, like 5 or 10 seconds of latency, like it isn't that much to us. Like if your Power BI report takes 5 seconds to load, it normally is fairly decent. And some of the bigger SQL queries might take even minutes to load. But caching basically works in a way that you use basically an intermediate database. So you get maybe a query. Maybe let's say you take data from your data set that's like always like I want data from only current date. Might be your cache hit. So when the first query goes in, it reads straight from the data source, but then after that it stores it in the cache database. And then when the next query comes in, it's a lot faster, and it's maybe 10 times faster at least. So you get like stupid fast results. And Azure has natively Azure Redis, and it's not that expensive, depending on your maybe API size. Like a couple of tens of euros might get you started, and I think in some tier was like 17 gigs was like 500. So depending how big you go, it can get expensive, but it's definitely a viable option. But you still need to be really careful with it because sometimes we tend to think that when we want low latency, we want fresh data. But often the fact is that applications just want low latency. They don't even might not want that fresh of a data itself. And sometimes you think that, okay, we want to every time we refresh our applications or stuff like that, we want new fresh data. But the data source itself refreshes like every maybe once a day even or less. So using maybe some sort of intermediate database like Redis might be definitely a viable option here. But like I said, you need to build strategies on this. You need to know on what kind of scenarios people are getting data out of this. So if you have like tons of different queries that people are using, like there isn't a single, like I want all data out of this date, people are doing like, everyone is doing a different query. That way caching can be quite demanding. There needs to be like 1 or 2 queries that are often used. That's when you can think about this. But in comparison, actually, I can show you a quick demo here. So let's check. So I'm going to talk this a bit about the second about the whole containerizing things and building an image. But what this basically is under the hood, it's just the DuckDB REST API that's built on top of Flask. So, and that's deployed on a container app. The whole image is currently living in my personal Docker hub, but you can obviously use Azure Container Registry or whatever you want. And we're going to talk about container apps versus AKS a bit, but right now I can show you how this whole thing works. And hopefully it works. And like I said, this is going to take a bit more time because I'm using a browser and the data is hosted and stored wherever. But as you can see, it brings out the data quite nicely. I'm just going to stop this so I won't use any of my credits too much. And like I said, we're going to talk about the whole technical setup a bit later. But comparing this is the one that most people are interested in. Delta Lake versus the raw Parquet. So raw Parquet in this means basically that we have the Parquet pipeline set up. We replicated the data from the Delta table to a single or a few Parquet files. when we are seeing these, and I have to say, these tests were done like 3 months ago or 4 months ago when the DuckDB Delta extension was in beta, and it still is, but it's getting faster every day because people are constantly developing it. But as you can see, when reading Delta Lake polars is still a tiny bit faster. I suggest this will change, but then again, we might not know what's going to happen in the future. But then once we go reading the Parquet file, we can see 0.25 seconds. It's really ridiculously fast. These will obviously change. These tests have been done locally. So if you have data set over in the States and you're reading it in Europe somewhere, Western Europe, obviously there's going to be latency there. So some edge computing thing it might be sensible to do in that way. What I also like in the DuckDB API is that it's fairly bit more flexible in a way that you would use polars. If you have some Pythonista developers who know their way around a library or two, polars is fairly easy to use. But the thing that is that if you use the DuckDB one, the whole, once I get back from this here, the whole basically the API looks in a way that it's everything else stays static. Only thing you need to change is the actual query you are sending it. And the query is basically just vanilla SQL. So basically you could just build a template and then deploy that template to a cloud. And then if someone else wants to build an API, they can just use your template. And only thing they have to mention or change is basically the SQL query. And that's really, really cool. For example, you can just, it's just a simple select query, or you can use CTEs or whatever. And DuckDB is actually, I don't want to say smart enough, but even if you mess up the ordering on select from where, it still knows on the actual order to execute those. So it's really flexible in a way, I might say. So that's one thing to think about. But like, and this 0.25 seconds is done without any intermediate database. So with Redis, you can get like 0.0 something if you want. And I think 100K rows and 20 columns, that's a query that I hope not too many people are running from a single REST API call. I think that's a bit much. So I think for most people, you could maybe use the Delta or the raw Delta as well, just do maybe a bit smaller API calls than 100K times 20. So one thing to mention, this whole presentation, I'm not going to go too deep into the whole deployment thing because this is something that you can talk about hours and hours. I say, if possible, use infrastructure as a code and CI/CD pipelines, but it's not an option. Hopefully, it's something that you need to do. If you do this in your own hobby environment or just a proof of concept, fine. You don't need to do any of these things. But if you are planning on building like a production grade stuff, you need to use this. Like, and like I say this in like the most softest fashion, but this is something that you cannot skip. And one thing I think that even if you have like not even say a big environment, but somewhat modern environment with modern tools, you have you use Bicep or Terraform or whatever, and you have some CI/CD pipelines already in place. The thing that I think most data folks are going to be scared or pushed away is the fact that you have to use images. This is again something that software developers and engineers do constantly, and building images comes as a second nature to them. But we as data people, we don't do this nearly that much that we could maybe implement this. So that's when you have to think about like package updates, file formats, and like even errors in your image. And like building a scalable Docker image isn't, the whole building apart isn't that hard. The hard part is that you need to think about, okay, what base image can I use? Can I just use some random image from the internet? Can I use something out of Microsoft stores? Does it need to have like an extra step on security checks even? It takes a while. And obviously you can deploy all of these using functions if you want to skip these parts. But I think for the near future, we might want to go and continue using maybe container apps or AKS. We can debate that in a few minutes. But yeah, these are not maybe like options. These are mandatory things you need to do or have in place if you want to deploy these things in a somewhat sensible fashion. Because other than if you just use like you're building an image and you just have random updates or no updates at all, you use package versions, just random, things are going to break really easily and really, really quickly. So I think this is a process that you might want to spend an extra time on if you're not familiar with it, and maybe if even like consider using a bit more time than you think about in this. If you're planning on doing this on a production grade environment, if just using like a proof of concept, obviously this is something that you can think in the next iteration. But yeah, those are basically options. So what's next? So we have discussed a lot about the technical things and the technical side of things. But when it comes to choosing the actual optimal solution for you, you have a few things to think about. Your actual physical and monetary resources, how much time and money and people you have. So if you are basically the only one doing these things, or you have a fairly small team, and maybe your business doesn't really understand or need these things, then if you need some kind of API solutions, I would suggest you go with the SQL endpoint. That's something you can handle on your own. That's something you can maintain on your own. Obviously, like I said, there are downsides to it, but that's if you're a one or two person team, there's no point in building these bigger pipelines and trying to optimize stuff. You need more resources in that sense. Other one is timeline. Whenever we are building something that's business critical, like hopefully some of these are, we need to think about the timeline. And one thing that I personally did is something that we start with maybe using the SQL endpoint, and that's something that's like our MVP kind of stuff. That's like we show that okay, you can people can query this API, but it's slow and stuff like that. And then we are going to actually think about that. Are we going to need lower latencies? How much customization do we even need? Then another thing is that we need to consider that is this a one-time thing? Are we going to replicate this solution endlessly, or is this something that is going to be done only once or twice? So what I would just suggest is that, for example, using the SQL database in between, it isn't that bad if you have a large environment and you are doing this once or twice. The whole point of building, like, if you don't have any CI/CD pipelines or image sanitation processes in place, it might be sensible to just go with that and maybe focus on some other aspects and do maybe this whole process whenever you have the time to do so. And then the other thing is that is this valuable for the business? So what I mean by this is that does the business actually need like an API for some applications or stuff like that, or can they actually just forget it and don't even use it? Is the data something that they actually need? Because building these things, obviously, they take tons of resources, or not tons, but some resources, time and money. So you need to think this in not in a technical standpoint, but from a business perspective. Is this something that is actually valuable to the client or in the project that you're working on, or is this just maybe another cool side hobby that you are doing? But here we are. So we talked about deployment, and now we're talking about basically the hosting part. You can basically do what I would suggest is to use container apps and then Kubernetes. You can obviously do tons of other stuff. You can do, like I said, functions, or if you use some intermediate SQL database, you can use logic apps, for example, and those work great and enable low latency as well. One thing that I am really excited about is the whole container app setup. those of you who don't know what container apps is in a nutshell, is just AKS, where the whole cluster part is abstracted, and Microsoft handles that. So you cannot do any kubectl commands or stuff like that, but you don't actually need to. What most of the use cases I've been to when talking about Azure Container Apps is that people don't really know how to use it that well. It isn't that popular. I've heard about people complaining something about networking restrictions, but there are so little of those. Mostly they are, or at least what I found was that if you want to build some kind of custom inferences and use some custom load balancers, and you have some custom requirements for those, then AKS might be for you. But then again, there's the issue that if you want to go with AKS, you need to have people who are doing mainly AKS. The whole cluster setup, you need to use some sort of deployment tool like Argo CD or stuff like that. It's a completely different subject. And if you have short timeline, I think most of us would agree that AKS isn't maybe the most fun project to be on. It takes a while to set it up. If it works correctly and you have great people maintaining it, it's fun. But I would say for most use cases, maybe using container apps is for you. There isn't any hard rule on how big you can go with container apps. Obviously, there's some sort of limit, but I would say is that even if you have like some, maybe you're talking about in the tens of containers or REST APIs, container apps is definitely for you. It works great. If you are talking about maybe in the hundreds or several, over 50 at least, then I would maybe consider using AKS. But again, that's also, you're in like a kind of in a scenario where you need to have, like, this is absolutely necessary that we build this, because it's going to take a while to build a good functioning AKS environment and set it up, deployment, everything. You have tons to work in there. So container apps is a ton simpler in a way. Yes. Then there's the possible architecture of the actual API. I've done this in a way that you have Delta Lake, and then you have central API, and then you have child APIs. There isn't any like right or wrong way on doing this. The main key this is that you can use the central API as basically that's the DuckDB one, where it queries data from the Delta Lake. And then if you want, you can have like APIs that query that central API. That's really, really easy if you want to maybe set up some, or obviously you want to set up some like security stuff, so who can actually read stuff from the Delta Lake. And also maintaining it, you can easily maintain your central API like quite easily. But I think for most scenarios, like this is more for, I'd say, if you are going with the Kubernetes kind of setup, because this takes a while to set up and think about. It isn't like impossible to do with container apps. But I would suggest that if you think about doing something similar to this, maybe consider the fact that you need resources and time and money that you want to build the Kubernetes stuff. Obviously, one thing to mention is that, for example, if you are building stuff that needs to be replicated to an on-premise environment, maybe AKS or using some sort of Kubernetes is the right one for you. But for most use cases, I would say that you can just do separate APIs that have the DuckDB installed, and they just query data straight from the Delta Lake. Because if you have, let's say you're in the tens, you can do security groups and whatever you want, and it's fairly easy to set up in a way. And if the amount of APIs basically explode, then you need to maybe think about doing something else using the central API, or do I even need these? Because often if you have tens of APIs, I guarantee there's at least one that isn't used that much. And one thing to also mention is that handling these APIs, maybe using API management in Azure is a good way of handling these. And that's, again, a whole other topic, building open API descriptions about this and stuff like that. But this is like the bare bones version of this. And I think that this part, the whole designing the actual API, is something that's not to be taken lightly. Sometimes I feel that when talking about this whole setup, people just tend to go for it and just build some random Docker image, and it's huge. It has unnecessary bloat, and just deploy it and forget it. But the actual architecture and the design of the API is key in here, because you don't want any like random API goals going to your Delta Lake or catalog, which aren't authorized to do so. So that's also one thing to mention, is that when building like this kind of setup in a production grade environment, it takes time no matter where you go. If you don't have the time or resources, then I'd say the SQL endpoint is obviously the way to go. Yeah, so I think I didn't see the clock. Hopefully, it took a while. If you have any questions, I can try and answer them for you. And on the down, you can see my LinkedIn, so you can also send me a contact request, and I will definitely add you. Thank you.